Hello, and welcome to Exploring Axon, a podcast where we discuss Axon Framework, Axon Server, and their ecosystem. I am your host and a software developer at Axonic, Sarah Torrey. In this episode, I spoke with Simon Zambrovski about event handling and Sagas in Axon Framework. We covered other topics such as query handling, storage, event processors, Axon Server, and more. Just a note that in this episode, Simon's referenced an episode about event streaming versus event sourcing that I recorded with Allard, but I mistook that episode with another one I did with Steven on message handling. So my apologies, but this is the one that I did with Allard that Simon is mentioning. But I do recommend you to listen to both of these episodes because they are both very much relevant to the topic of this conversation. So I really hope you enjoyed this talk. It was very, very informative and wonderful. And let's have a listen. Hi, Simon. How are you today?
Hi, Sarah. Thank you. I'm fine. How are you?
I'm doing great. Thank you so much for joining me again today for some really great conversations. I always enjoy talking with you, so I appreciate you joining me today. So let's talk about one of those topics that comes up quite frequently when we talk about CQRS and event and command handling. So we're focusing today on event handlers. Can you tell me a little bit about them and why are we talking about them? Why is it important to talk about event handlers?
Yeah, with a pleasure. So actually, I think you spoke about many facilities of Axon Framework already and covered a lot of aspects of them. Um, and your podcasts are just great because they go really deep and extend the understanding of the framework and the method in general. But
Thank you.
I'd like to discuss more things how you can use these facilities to construct the new systems and why are they actually built in a way they are built.
Mhm.
And how to use them as basically building blocks during the design of your application.
Mhm. So I'm glad you brought up the design of the application because that's where it all begins, right? When we talk about CQRS, that's basically the architectural structure that we're using to make it a little bit, in some ways, a little bit more complex because there's a lot of time and effort has to go into the designing the application, but eventually it makes it a little bit easier to expand the systems and make them grow as we uh, have these business ideas and business demands change. We have to, of course, change the system. So CQRS actually helps with that. So, but let's dive a little bit deeper into that. And of course, we're sort of, as we're talking about events, we're in the middle of commands and queries a little bit. So let's discuss that a little bit.
Yeah. Yeah, in general, there is this notion of change, right? So the command accepts something, the command model, and then the query model eventually needs to know about this change, right?
Right, right.
So, and there are many ways how you can implement that. And Axon provides us with an idea to say, just use this notion of event
Right.
to transport this change from the command model to the query model.
Mhm. Right.
And yeah, also there are many implementation of events in
Mhm.
systems, and in Java it's usually it's just a simple pojo, so plain
Mhm.
all Java object,
Mhm.
and then it just serialized to some message and then sent over to the query model.
Right.
So in the same time, we know if our aggregates use event sourcing for persistence,
Mhm.
then we use this same serialized message and store those
Right.
messages inside of an event store, and
Mhm.
then an aggregate can yeah rehydrate itself. Well, the command model can rehydrate itself by replaying all those
Mhm.
events for a particular aggregate and then
Right.
getting state back, right?
Yes,
So
of course.
this is this notion of not only having CQRS but CQRS ES, so having event sourced aggregates, and then we have a single point of truth, which is
Mhm.
basically this stream of events that is used.
Right, absolutely. And when we're generally speaking about event handling, we're basically these are the event listeners, right? Where we have a command sending the request, and then this event is actually um, acting on that command that is being received. So whether we're trying to update a view model, for instance, or forward these updates to other components like third party integration systems or something like that. But also, in some cases, we do have event handlers that throw events themselves based on whatever patterns of events that they're receiving it from, so that they can even send commands to trigger further changes, which we will talk about a little bit later in our discussion. But let's first focus on the receipt of the event messages. Can you tell me a little bit more about that?
Um, yeah. Yeah, as you said previously, so one of the core idea why we need those events is basically this transport mechanism between the command model and the query model.
Hmm.
And in contrast to command model, where we have aggregates and there is a lot of helping infrastructure from the Axon framework how
Right.
to build it. In query models are much more easier to construct and to build.
Hmm. Hmm.
Essentially, these are components which provide two ways, or basically two classes of methods
Right.
to the framework. One are event handlers, and the
Mhm.
others are query handlers.
Right.
And event handlers is a way to feed these query models with new information.
Hmm.
And basically, we react on events or on an event stream
Hmm.
and fill up our data, right? And the
Right.
query models are the opposite. That's the way how to read information from these
Hmm.
query
Hmm.
models, right? So this is, if we submit a query, is being dispatched, and then the query model is being picked up by calling the corresponding query handler.
Right.
And yeah, and Axon Framework provides us with a very easy way of implementing those. So the
Hmm.
usual methods with special annotation,
Right.
and these annotations, being scanned actually, and then we get a callback in our system. And
Hmm.
there is nothing more beside of that actually, and this is very very important. So it's that easy. So there is no one tells you how to build the query model, right? So you
Yeah.
can you
Yeah.
can you can decide um, what to do,
Hmm.
and you can decide how to store your data, if you want to
Yes.
store your
Yes.
data or not.
Yeah.
You may store it in memory, you may store it in a relation database, you may store it
Hmm.
in
Hmm.
NoSQL storage, you name it, Elasticsearch.
Yeah.
It depends on your use case.
Of course.
and
Yeah.
and this gives you a lot of flexibility, and that's the
Sure.
reason why there is actually no first level support for the query
Hmm.
model itself, or for query
Right.
model persistence.
Yeah.
Because it's up to you, how to build it.
Exactly, and I think that makes it very flexible on the storage side of it, because as you mentioned, there are no clear cut rules or set in stone. Like, you have to store it this way. It has to be, say if you want to store it in MongoDB, that's fine. If you want to store it as a SQL, that's fine. Of course, we normally recommend them to be sort of denormalized, so there's not a whole lot of coupling going on, so that it's easier to manage those queries. But of course, if you want to, that's of course fine too. So going further a little bit, are there any considerations or design decisions when we're constructing a query model?
Yeah, indeed. So there are several things you should reason about.
Hmm.
So I think it's always a good idea to design it from the query side, so not
Right.
from the event side, and actually optimize it for query performance. You just said it. Denormalized is a good idea. So
Hmm.
if your query gets in, you don't want to join across columns, right?
Right. Right.
So you should store it in a way you retrieve it, and
Hmm.
you should make sure you have good indices on everything. So it should be a very fast retrieval of the result.
Right.
Um, another rule is, in general, you don't want to share query models for different purposes.
Hmm.
So it makes sense to create specialized, tuned query models.
Right.
And even if you have kind of a feeling that you have a code duplication,
Mm-hmm.
that's okay, because it's kind of cheap to
Right.
create
Right.
this, and you get flexibility out of that. So you
Mm-hmm.
can later on you can decide, I have to tune this query and I have to tune that query, and these tunings usually go in different directions.
Right.
So it's a good idea to basically to have separate query models.
Mm-hmm.
And during this, you want actually, so it's kind of the opposite of this CRUD based design, where you say, you have a
Right.
central uniform yeah referencing itself complex data model that is
Mm-hmm.
being tracked,
Right.
and it's all about normalization. Here you say, exactly the opposite. I
Yeah.
denormalize
To
for a
normalize it. Yeah.
specific query to get
Mm-hmm.
maximum performance during reading,
Mm-hmm.
and I don't care if I have duplications.
I see. Yeah, that makes sense. And um, can we talk about a little bit on? I had a conversation with Stephen a few weeks ago about event processors and the tracking event processors. Can we touch on that a little bit as well here?
Um, yeah, so the difference in processors is actually, I mean, you have this subscribing and tracking, right,
Yes,
as
of
the
course.
two existing, and there is the
Mm-hmm.
third one, as I understood your podcast in
Yes.
doing, which is
Yeah.
very interesting topic in fact. Um, uh, yeah, so if you build a persistence of your query model,
Mm-hmm.
then it's up, to you basically to decide, what kind of it is following the event stream, and it needs to know where it is in this event stream.
Right.
So how eventually are you with your query model in contrast to the source of the events,
Mm-hmm. Mm-hmm.
right?
Right.
And to track this, uh, actually there is a notion of this tracking token, right?
Tokens. Yeah.
So
Yep.
this tracking token shows you a position in the event stream,
Right.
and the tracking event processor tries actually to keep up with the token, and
Yep.
to be up to date all the time.
Mm-hmm.
And
Mm-hmm.
so this is the way how you basically, if you're using tracking event processors, this is the way
Right.
how you keep up with the changes.
Mm-hmm.
The
Mm-hmm.
advantage of having or using tracking processors, event processors, is that this can be executed in a completely separate thread, so it's
Right.
independent from the production of the events from the
Mm-hmm.
source, and it's just keeping up with the changes.
Right.
Um, and in general, it's a good idea to have so this tracking token, you need to store it somewhere, and
Mm-hmm.
Axon provides a wonderful abstraction for doing this. There is a
Right.
so-called token store,
Mm-hmm.
and in general, it's a good idea to store the token in the same way the query model persists
Right.
itself. So
Absolutely.
if you use MongoDB for query model, then use the Mongo token store for the
Yeah.
token.
Yeah.
And if you're using a relation database, it's a good idea to use relation. And if you have, in memory model, then there is an in memory token
Sure.
store. So
Absolutely.
they should be in sync.
Mm-hmm.
Um, because imagine you are in memory.
Mm-hmm.
This means, if you restart your component, you are forgetting everything. Then
Yes.
it's
Of
actually a
course.
good idea to have, if you're forgetting the state of the query model, you should
Mm-hmm.
also forget the token, right?
Right.
Because the
Absolutely.
token then would your tracking processor would say, okay, I have no token, so I have to start
Mm-hmm.
with the beginning. It
Right.
will
Right.
get up the full replay of the event stream, and the model will be up to date, right? So
Yeah.
this is kind
Absolutely.
of, it fits together, that your primary persistence of the
Yeah.
query model and the token
Yeah.
store should use the same technology.
Yeah, absolutely. And um, the actually the episode that I did with Stephen, we discussed the replay of all of these events in detail as well. So if anybody's interested, that's discussed as well. Um, and also, spoiler alert, I will in some future episodes, not sure exactly when, but I will cover MongoDB as well as Axon Server as a an event store. But kind of let's come back to the notion that we talked about. The event handlers are connecting the command and query models, as we discussed a little bit earlier. So are there any other use cases for event handling components?
Yeah, good that you ask. Apart from this query model itself, there are several other components or maybe even scenarios
Mm-hmm.
where you might want to use event handler.
Right.
And if we go and speak about them, I'd like to focus, or basically, it's not a focus. I would just name this because this kind of
Mm-hmm.
there is this notion of handling side effects,
Mm.
which is pretty important for what does it mean for DDD and CQRS in
Yeah.
general. And so,
And what do you mean
and
by side effects?
yeah, I mean, you had this wonderful podcast with Yvonne, for example,
Yes. Yeah. Yeah. Yeah.
and you were speaking about set-based validation.
Yes.
Yeah.
Yes. Mm-hmm.
So for everyone who hasn't had time to listen to it yet, just do it.
That's
It's
a really good
very
one. Yeah.
interesting. It's a good one. But just a small summary. So if you want to validate a constraint on set of values, and this set is
Mm-hmm.
basically part of your command model
Right.
and represented, for example, by a set of different um, aggregates. Yeah,
Mm-hmm.
so there is no this single instance whom you can ask and say, give me is my command valid or not? But you have
Right.
actually to ask all of them. So
Yeah.
it's obviously not easy to maintain. So
Right.
imagine we have something like, I don't know, we have customers, and customers need to register with their email address, and we want to make sure that every email address is unique in our system. So we
Right.
shouldn't reuse them.
Mm-hmm.
And since every customer would be represented by the aggregate, there is no place where we can say, give us the check if this email address is already used or not. And the
Yeah.
email address is not the target aggregate identifier, so we cannot use the Axon Framework underlying infrastructure to check that. So in this case,
Right.
there will be the technique is in general independent how you hook up this validation inside of your
Mm-hmm.
code.
Mm-hmm.
You'd like to check against the strong consistent storage and not about the eventually consistent storage, which
Mm-hmm.
means that you have something like a backing table that
Right.
contains all email addresses of all customers that ever registered,
Mm-hmm.
and you check against this table during your command dispatch, and in the same transaction you are writing a change to this data
Mm-hmm.
storage, right?
Right. Right.
So this is the idea. So you say, okay, in the
Mm-hmm.
beginning you have nothing. The first time you say I create the customer, you check, you find out there is nothing,
Mm-hmm.
and during this transaction commit there will be a modification to a email address table, which will then contain the email address of the first customer.
I see.
And
Right.
since Axon Framework provides this notion of handling or dispatching command one after another, you have a
Mm-hmm.
strong system and strong consistency on the aggregate level,
Yeah.
and this will lead basically that, so you have a full serialized stream of commands actually, and
Right.
that
Right.
means that you can basically use this backing table as for reference.
Mm-hmm. Mm-hmm.
And so why it's a side effect? Yeah, from aggregate's point of view, of course it's a side effect, right? So it
Right.
has
Right.
nothing to do with the primary persistence of the
Mm-hmm.
aggregate itself.
Right. Right.
It is not a member of aggregate. It is,
Yeah.
if you model it as an aggregate, there is something like and technically, and Yvonne speaks about this, technically you will have something like an interceptor probably in the
Mm-hmm.
command dispatching
Mm-hmm.
way,
Yeah.
or you have a special service injected to the aggregate.
Right.
But it's not, if you choose, for example, to use event sourcing,
Mm-hmm.
it is not event sourced.
Right.
It is just hooked in using the framework,
Mm-hmm.
and this modification is also hooked in during using the framework, right?
Right. Right.
And typically you hook in this change or this modification actually as a subscribing event handler.
Mm-hmm.
Subscribing,
Mm-hmm.
because using subscribing in the same virtual machine will lead up to executing the event handler in the same thread and in the
Exactly.
same
Yep.
transaction.
Mm-hmm.
And this is exactly what we want, right? So we
Yes.
want to make sure that the transaction that is used for the
Mm-hmm.
dispatching of the command is
Mm-hmm.
used to modify these storage.
Right, absolutely. And one of the things that you mentioned as we talked a little bit before was the notion of if this happens outside of the bounded context. So let's discuss that a little bit. So um, when we did talk about aggregates a little bit, let's maybe start with that. So inside of an aggregate with this in the same bounded context, how can we use this sort of the notion of the CQRS and event sourcing application and basically handling our events?
Yeah. Okay. So inside, yeah. Okay. So inside the same bounded context, it's if you look on the CQRS application or
Hmm.
especially Axon application, um, then an aggregate is just just have a kind of structural view on this, on like system thinking, right? We
Right,
just
right.
say it's a small device, and what
Hmm.
can it do independent from the functional logic it's implementing?
Yeah.
It is receiving commands and
Hmm.
emitting events, right?
Right.
So if I have one of that, that's kind of easy what to do.
Hmm. Hmm.
If I have two independent of them, so I have two consistency boundaries inside of my bounded context,
Right.
which are responsible for maintaining this consistency independent from each other. So I can,
Hmm.
then if I want to connect them, I have just a structural problem, right? Because
Yeah.
they're
Yeah.
emitting events and I have to consume commands. So there must be a bridge between them, right?
Exactly. Right.
Uh, but yeah, so if you do DDD and basically do the requirement engineering, one of the methods of collaborative modeling or
Hmm.
yeah, event storming or whatever, then there is a notion of this, right? So
Hmm.
there is
Hmm.
a notion of a of a rule that is described in terms of condition action.
Okay.
Um, and yeah, so people call it policy, or sometimes it's
Hmm.
called business process.
Right.
And so just to give you an example, so imagine you have an aggregate that is, we are building an online store or whatever.
Right. Hmm.
So, and we have a policy which says that whatever an order is placed,
Hmm.
um, a payment must be executed, right?
Sure.
Because we
Right.
want that the orders are being paid at some point
Yeah.
of time. And now imagine we model this. We have two aggregates. So we
Hmm.
have an aggregate responsible for the order management, and the
Right.
other aggregate responsible for this payment stuff.
Payment. Hmm.
And yeah, so what if the command comes in the order placed event is
Hmm.
being emitted by the first aggregate,
Right.
then and the payment aggregate needs to get something like execute payment command, right? So
Right. Right. Right.
and now we need some component that is listening to this order placed event and says, okay, now this event comes in and I have to apply this policy,
Hmm.
um, or yeah, and then we need to basically send out this execute payment command, right?
Right. Right. Right.
So this is the kind of this kind of bridge
Yeah.
between the two aggregates, um, yeah, that we need to build. Okay,
Hmm. Hmm.
and now it gets really interesting because what happens if essentially execute payment command is rejected by the corresponding aggregate. I
Right.
mean,
Right.
it's responsible for its consistency state on its own, and for some
Hmm.
reason it can say, execute this payment command is not valid in this context.
Hmm.
So in
Hmm.
principle, this situation exists,
Yeah.
and yeah, so how to react to that, right? So because I
Exactly.
mean,
Right.
we already send it as an event from the one, and now we
Hmm.
need uh, yeah, and so um, if we have a subscribing event processing used to connect those two,
Yeah.
we might configure it in a way that it will propagate the exception to the origin, right? So
Yeah.
usually it's not.
Yeah.
Usually it will just skip an exception, so yeah, no problem. But you
Hmm.
configure an error handler on that in a way
Hmm.
that you propagate the exception basically to the origin.
Right. Right.
Uh, and if you run on the same machine, that would mean that, propagating to the origin means propagating to the same to the first unit of work of the first aggregate.
Right.
And this and this unit of work is responsible for dispatching place order command.
Mm-hmm.
And this means that, we created kind of a pushback,
Mm-hmm.
actually,
Mm-hmm.
which is a good thing, because we
Yeah.
wanted this policy to be executed, and one of the steps is probably not executed. So we
Mm-hmm.
should basically roll back all this and say, this dispatch is not possible for any
Right.
reason,
Right.
right?
Mm-hmm.
Yeah. So this is how it can work if you choose correct event handlers
Mm-hmm.
to communicate. By the way, if we in this case would use tracking event processor,
Mm-hmm. Yes.
then you have no chance of actually communicating back, right, to the source,
Yeah. Yeah.
because tracking is just reading a series of facts.
Mm-hmm.
I mean,
Mm-hmm.
our event stream is already published, it's already stored,
Right.
it's already there, and the tracking processor can just say, okay, I'm reading something, there is an event saying, okay, we have basically order placed event, so I
Right.
have
Right.
to
Right.
react on this. My command dispatcher refuses to execute payment command for some
Mm-hmm.
reasons,
Mm-hmm. Mm-hmm.
and the only thing I can do, I can send a command back to the first aggregate,
Right. Right.
but I cannot prevent this aggregate from doing anything, because it's already done, right? So it's already
Exactly.
history.
Yeah. Mm-hmm.
And this is how this event handler processor can be used, if you have different requirements in mind. So if you want
Right.
this pushback, subscribing may be a good idea.
Mm-hmm.
If you want to say, I'm just publishing facts to the outside world,
Then
then
tracking would be.
it's a tracking, exactly.
Yeah. Absolutely. So this is within that same bounded context, and another spoiler alert, I will have an episode about bounded context where we really explain what they are and how you can basically choose which aggregates belong to which context. So um, in this case that you brought this example of, okay, we have the aggregate where it manages basically the receive of the order, and then another aggregate which manages the payment. So now let's say we put these into different contexts entirely. So there are two different bounded contexts. One context is taking care of, say, receiving your orders, and the other context is taking care of the payment. Or we can have another system entirely that's a third party system that takes care of these. So basically, talking about having different bounded contexts that need to then communicate amongst themselves, right? In that case, we have to have something else. So we can't really just simply use our event handlers and say, okay, communicate this command to this query, or even in some cases, as we talked about, send even commands to trigger further changes, for instance. So if we have two different contexts and we have to communicate between those, we need something that basically sort of translates in between these two contexts. Can we talk about that a little bit? This is one of my favorite topics, so I'm
Yeah,
so excited to talk about this. So tell
very
me,
good, very
tell me
good.
more.
Before we go to this, I'd like to. I
Hmm.
mean, we spoke about a very kind of very simple case, right, where we have two
Yes.
aggregates, and everything that you handle. I mean, essentially, you are handling it completely on the color stack,
Hmm.
because the policy was so trivial, like to say if this then then, and
Yes.
there was only
Yeah.
one condition, right? So if
Hmm.
we have only one condition, we don't really have I mean, we have a state, but we can't have hold this state on the stack, right?
Right. Absolutely.
And so this event handler is kind of stateless, because it doesn't need to provide any information, or basically connect any information together, and
Hmm.
any information. It can just act if this method is called, especially if there is an event handler that is being called, then just create a command and send it over. Um,
Hmm.
it gets more interesting if this process has several steps, right? So if
Right.
we
Right.
say
Right.
uh, we have multiple condition that needs to be met and only after several events are received, we can store it. So
Yes.
then in this situation, we get a state of this business process itself.
Right,
So
right,
it's
right.
not a state of the aggregate,
Mm-hmm.
but we wait for, I don't know, customer is registered, order is placed, and order is
Right.
confirmed, for example,
Of
right?
course, yeah.
So there are
Mm-hmm.
several conditions we need to wait until we say, okay, now we need to initialize the payment.
Right, right,
Okay,
right, right.
so we get this notion of business process state,
Mm-hmm.
and in our example, we can just going further and staying by this order shipment and so on. We can say, we want to ship, so it's another component, and we want
Mm-hmm.
to make sure that it's shipped after the payment has been executed and the item is available in inventory, for example, right?
Mm-hmm.
So two
Mm-hmm.
conditions.
Yep.
Okay, and so both of them will run in the same bounded context, but
Yes.
run by different aggregates.
Yeah.
And so we have kind of small business process, which is
Mm-hmm. Mm-hmm.
started by order placement, then making sure the payment is there, then we
Right.
have something like inventory check, and then we have this, and then in the end we are sending up our shipment.
Right, right.
um, and the instance of this event handling component
Mm-hmm.
responsible for this business process needs to know what conditions are met already
Mm-hmm.
and what steps are already performed. And they
Yeah.
don't have to be in this order, by the way, right? So they can
Mm-hmm.
be, we can allow to say, it doesn't matter in what order. If we first pay and then check the inventory, or another way around,
Mm-hmm.
this is
Mm-hmm.
completely flexible.
Right, right.
And still we don't want to enforce the synchronous communication. So usually we just say,
Sure.
they are asynchronous, so they can complete to any random times,
Mm-hmm.
and
Mm-hmm.
after that we have some result, right?
Right,
So-
exactly.
and
And
the interesting story about this, in order to implement this, the easiest way to implement this is
mm-hmm.
that we will introduce some fields inside of
Mm-hmm.
this event handling component,
Right.
which are responsible for holding this state. Okay, so we
Yeah.
will say, okay, we check the inventory.
Mm-hmm.
So this is kind of stateful information, right?
Right, right.
And the payment is completed. Okay, we
Yes.
we have a
Mm-hmm.
we have a success on the payment, and this is
Right.
another one. And only after all of them are set, we will send up the basically the corresponding command.
Right. Right.
And
And
yeah,
yes, go
yes.
ahead. Yeah.
So this is the so before switching from distributing aggregates to different one, there is also
Mm-hmm. Mm-hmm.
inside of the same bounded context, you
Mm-hmm.
have this notion of stateful event handler.
Right.
And this is and in the end, if we have a state, so we this that's the next challenge that comes in. If
Mm-hmm.
As long as you are stateless, you can use the same instance of a class actually to
Right.
handle multiple business processes, right? Because I mean,
Yeah. Yeah.
they just call the methods and then they are done, right?
Exactly.
If you're stateful, you cannot do that, right? Because you need
Mm-hmm.
to track now that this is the order that is already paid, but the inventory is not checked, and that's
Yeah.
another order with another
Yeah.
ID basically.
Mm-hmm.
And there the inventory is already checked, but the payment is not full. So
Right.
you have
Yeah.
different instances of these business processes in your
Exactly.
system in the
Mm-hmm.
same time,
Yeah.
and then there must be a way how basically to find them, right?
Yes. Exactly.
And
And
so coming back to your question, Axon Framework
yeah.
helps us already there.
Right. 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 I was
So
going to ask you, does Axon Framework do something for us
yeah,
here?
of course, of course, of course, of course. I mean, there is a special artifact provided by the Axon Framework, designed
mm-hmm.
exactly to support this use case and
Yes.
exactly for this purpose. So its current name is Saga,
Mm-hmm.
and there are some
We may
rumors.
change that.
There are some rumors of changing the name to the process manager, not to confuse people with uh, you know
Yeah.
there are some people outside there who basically studied computer science and databases
Right.
and know that there is a
Databases.
Saga pattern there.
Yes.
And
Not to be confusing there.
yeah
Yeah. So
not
there, it's in the discussion phase still as we, what the next name might be, or if that's going to be changed. But yeah, absolutely. Yeah.
so
So,
if you want me kind of, as a definition, I would say the Saga is a stateful event handling component that is capable of
Mm-hmm.
holding a process state. Okay, so
Right.
that's why we have this guy.
Mm-hmm.
And yeah, so the minimum state that we have is actually the position in our business process, right? So
Mm-hmm. Mm-hmm.
kind of, in um, I told you in previous times that I'm doing a lot of business process management stuff
Yeah.
with
Yes.
process automation. And
Mm-hmm.
there we have this so-called token analogy. So
Yeah.
if you imagine that you have a process model, like
Mm-hmm.
graph, like a
Mm-hmm.
BPMN model, for example, then if you start an instance, then you can imagine that you just you put a token on it, like
Mm-hmm.
on a game, yeah, on a tabletop game, just putting a token in
Right.
some place, and this token travel across the business process model until it's
Mm-hmm.
finished.
Are you
So
doing this? I have to ask. Are you doing this in your table soccer game that you were designing as
no,
well?
no, no. We do actually we don't we do have some processes there, but not a lot of them,
Yeah. Okay. I
because
just had to ask because that was such an interesting topic we talked about last time.
yeah. So this token analogy is so it's the same here, right? So if you have a
Mm-hmm.
business process, you can basically say, okay, at least I need to know where I am in this business process,
Right. Right.
um, and yeah, and sometimes yeah, and you actually to track this token, there are
Mm-hmm.
different ways how you can do this. You
Mm-hmm.
can just introduce a state variable saying where I am. In addition to this, it's pretty common that you accumulate values during this business process,
Okay.
because some values are delivered by the events in the very beginning of this business process,
Mm-hmm. Mm-hmm.
and you need this information later on as you send out commands,
Mm-hmm.
and you need yeah, basically the same information. And
Right.
there are
Right.
some
Right.
intermediate events that are not carrying this information, and then you say
Mm-hmm.
like, okay, I need to store this.
Mm-hmm.
Yeah. So
So,
this
how
is
does the persistence of sagas work?
Oh, that's a very interesting topic. So I think it's one of the yeah, it's kind of challenging.
Mm-hmm.
We can speak why it's challenging. I think it can be less challenging, I hope,
Yeah.
at some point. um, yeah, so Axon Framework is not really taking care of, or let me put it differently. It does of course it does take care as usual, but the Axon server is not taking care of this.
Mm-hmm.
This is maybe the reason why you run into this. So Axon Framework itself just offers you to configure serializer,
Mm-hmm.
which is responsible basically for converting this the value or the instance of a Saga class
Mm-hmm.
uh, into something that can be stored. So
Yeah.
it's serializing the value and deserializing the values.
Mm-hmm.
And of course, you can use different implementation for storage,
Mm-hmm.
as usually in Axon Framework. So you after it's serialized, you can say, okay, I want to store it in GDBC. So using relation database and GDBC mapping,
Mm-hmm.
or GPA and Mongo or whatever, right? So
Yeah.
or
Sure.
on your own
Mm-hmm.
if you want to implement one.
Right.
So there is a Saga store which is responsible for writing it down and
Mm-hmm.
reading it back, and there
Mm-hmm.
is a serializer responsible for doing this, how to construct a class from essentially a blob or a string
Right.
or whatever, and back.
Mm-hmm. Mm-hmm.
Um, what was at least confusing to me at some point.
Mm-hmm.
I mean, in you have the test fixtures to test sagas.
Yeah.
Is the same way how you have them for the aggregates. You
For the
have them for
aggregates.
sagas,
Mm-hmm.
and those are intended to test that the process runs correctly,
Mm-hmm.
right? So it's what you're testing there is this notion of you are expecting some events to occur, and you make
Right.
sure that the commands are dispatched.
Okay.
Okay,
Yes.
so this connection is tested,
Mm-hmm.
not the persistence. This is very important. So um, in addition, so what I do now, definitely every time, I always test serialization on deserialization of sagas. So I'm
Mm-hmm.
writing
Mm-hmm.
dedicated tests.
Right.
We just make sure that a saga can be loaded from a minimal set of data,
Mm-hmm.
and then some, some full set of data and
Right.
serialize
Right.
back. So I'm
Mm-hmm.
really testing the serialization, because if you forget to configure it correctly, or your
Right.
serializer is not working, or your class is not serializable because
Mm-hmm.
you just messed up with the JSON properties, and you're using a JSON serializer,
Mm-hmm.
and JSON serializer is like Jackson is sometimes evil in terms of it throws exceptions if it cannot work, and
Right.
sometimes it's even more evil. it
Mhm.
it just do nothing, right? Okay, so it just does.
That's worse. Exactly.
Yeah, it just ignores what is you're saying there. It's just
Right.
deserializing you an empty object, and you say like, okay.
What just
um,
happened? Yeah.
exactly. And this is, if you don't test this, it's tedious, because you're kind of,
Mhm.
you have a test that tests the ability of the Saga to work.
Right. Right.
But in production, it's you're looking in the so the trick is to look on the database table in the end, and to
Right.
look what is being stored. And if
Mm-hmm.
you see an empty JSON object, you probably missed something.
You're doing something wrong. Yeah.
Yes, because probably this is the problem then, because then
Right.
what Axon Framework does is then to find the correct Saga, and to
Mm-hmm.
load the correct Saga. But if it's empty, it doesn't have any
Mm-hmm.
state, so you're not going to make any progress in your
Right.
business process, right? So you're
Mm-hmm.
you're
Mm-hmm.
still kind of on the wrong track.
Yeah.
Yeah. So this is so it won't actually perform as expected if the serialization is not
It's not
correct,
working.
and
Yeah.
the best way to do this is just test that.
Test that. Yeah, of course. So, just in parentheses, I think it's also important to mention the annotation for Saga as well, because we always have to have the at start Saga. And do we always have at end Saga?
Yeah, there are I'm in consultancy, so it depends. As usual, it
My
depends.
favorite answer.
Yeah, no,
It depends.
actually not. So yeah, there is a notion of end Saga annotation, so you can
Mm-hmm.
just put it on the event handler, and that
Yeah.
means that the event handler that is so it's being executed, and after
Mm-hmm.
it's executed, this Saga will be ended,
Will end.
which
Yeah.
means it will be deleted from the database and so on.
Mm-hmm.
There are, but putting annotation on a method means it's unconditional, right? So
Right.
independently
Right.
of what happens inside of this method, in the
Mm-hmm.
end, it's over.
Mm-hmm.
If you want to put it in some conditional blocks,
Mm-hmm.
then you have a Saga lifecycle, which is similar to what you have in an aggregate.
Yeah. Yeah.
And there is a method which is called in Saga, and it's a
Mm-hmm.
static method. You can just call it inside of the Saga execution, and then
Yeah.
you have you may have some conditions like if then
Mm-hmm.
else, and then
Mm-hmm.
in some case you end up with
And
Saga,
it's
in
yeah.
some cases you're not. Okay,
Yeah. Makes sense.
so that's the way how you conditionally end up.
Mm-hmm. Makes sense. So, kind of going back a little bit, can we talk about the Saga Association and what is that?
Yeah, we briefly mentioned that actually. So
Mm-hmm.
there must be a way how your correct instance of a Saga is found, right, inside
Yes.
of the application. So
Mm-hmm.
if
Mm-hmm.
we in our example, we have like you know we have hundreds of orders in our system,
Mm-hmm. Right.
and now and one of the aggregates fires uh, a relevant event, and the Saga
Mm-hmm.
needs to be notified, right? So the
Right.
question is how to find the correct one.
Mm-hmm.
And for that purpose, Axon Framework provides us with so-called Saga associations.
Mm-hmm.
It is some information that is also persistent by the framework itself,
Right.
and so the idea it's kind of similar to what the aggregate and target aggregate identifier
Identifier.
in
Yeah.
the command handling and dispatching is used, right?
Right. Right.
So there is a notion of there is a notion of identification the correct Saga from the values of the event. Okay,
Yes. Yes.
but in contrast to the aggregates where it's easy because the command must be directed to exactly one guy, right?
Right.
So you have this direction, and
Mm-hmm.
there you need exactly one field to identify the aggregate.
Right.
In Sagas, it's not like this, because the Saga can say, I'm listening to different events,
Mm-hmm.
and they can come from different aggregates.
Right.
So
Right.
there might be multiple identification inside of this same
Mm-hmm.
business process. So
Right.
in our
Right.
example, we could have, the order ID could be an identification of our business
Mm-hmm.
process, the
Right.
shipment ID, the payment ID, and whatever, right? So there,
Mm-hmm. Exactly.
and you just associate these IDs to your
Mm-hmm.
Saga,
Mm-hmm.
and then inside of the event handler, you can make sure that, so having the Saga event handler, you can say what field inside of this event
Mm-hmm.
denotes one of the IDs
Right.
that your association with is
Right.
maintained, actually.
Mm-hmm.
Okay, so that's the way how Axon frameworks routes events to correct Saga instances.
Right. Right.
So yeah.
And talking a little bit about annotation a little bit also. So when we have that Saga class, because that was one of the things that I was a little bit confused about when I first came across the notion of sagas. So when we create a saga, of course, at the beginning, at the top of your class, basically, you have the add saga to uh, notate that this class is going to be a saga, and that basically lets the framework know to do certain things, and that the framework does so wonderfully. The other thing that we briefly talked a little bit about two bounded contexts, and this is one of the things, or in between two aggregates for that matter. Um, I think it's also important to note that at the beginning, as you mentioned a little bit ago, that we have to have the identification, some sort of identification on which aggregates we are communicating this saga in between, right? So, for instance, if you have your payment uh, aggregate and then you have the order aggregate, the IDs of those, or the aggregate identifier has to be included within the Saga class so that we know exactly which ones the Saga is communicating with. And as you just mentioned with the association, with the Saga association, the when we do the start aggregate, so or start saga, excuse me, when we have that annotation of at start saga, and underneath it we use the at saga event handler. I think that's also important to mention, because it's not just a simple event handler, it
Yeah.
has to be the at saga event handler. Then right after that, in parentheses, it's where we're putting the association. So the association property is the aggregate identifier of the first aggregate you want to communicate, and then the next one is the association of the other aggregate, basically, you want to aggregate to communicate with. And when you mentioned the end saga, sometimes it depends, right? If there was a saga that one of my colleagues and I were working on. Actually, she was working on it, and I was kind of watching the process as she was going. And we did start off the aggregate because, or started the saga because we were trying to communicate with the first aggregate, and then we used the end saga for the second aggregate because we wanted this saga to have that state where it actually there's an end or the life cycle of the
Yeah.
saga, if you would. So then the association property then of course goes to the second aggregate in our case, for instance. But if you don't even have that end saga annotation, you still have the association, correct? Where
Yeah.
you basically tell it where this second event has to be handled or come
By the
from
way,
or
if
what
you don't
not.
put the end saga at all,
Mm-hmm.
it will be persistent forever. Um, I mean, you have to think about this.
Mm-hmm.
For small systems, it might be okay,
Right.
but I mean, it's just. I mean, it will live forever in your database,
Yeah.
and
I
there may
don't know if
be
you
reasons
want
why
that.
why
Yeah.
you think it's a good idea, but essentially, there should be some way of ending a saga.
Yeah. Yeah.
Um, Yeah. So I'd like to. You asked actually some times ago about this. What happens if we communicate a cross-bounded context?
Mm-hmm. Mm-hmm.
This is very interesting, and I love this. This is kind of this wisdom of DDD. You
Mm-hmm.
just encounter it again and again. So DDD spends a lot of effort of this context mapping in relation between different
Right.
business bounded
Mm-hmm.
contexts in the strategic design, actually.
Right.
and there is a bunch of patterns describing the possible integration between them. You have this partnership where they're kind of
Mm-hmm.
equal.
Mm-hmm.
And then there is this customer supplier, sometimes called upstream downstream,
Yeah.
where the one is kind of basically
Your core
saying
system,
what
basically.
yeah,
Yeah.
kind of core system, and the other one is
Mm-hmm.
just accepting what is coming in.
Right.
And then in this customer supplier, you have these different terms introduced, like you can be a conformist where you just accept the ubiquitous language of supplier, so you just
Yeah.
say, okay, I'm kind of a bounded context with my own language, but in
Mm-hmm.
if that guy speaks to me, then it's fine. I just take the words he's using.
Yeah.
Sometimes you're not willing to do so. So sometimes you
Mm-hmm.
want to translate, and this is called anti-corruption layer. So
Yeah.
you adopt the supplier ubiquitous language to your own language.
Mm-hmm.
Then sometimes there is this open host service where I have a public API, and this
Right.
is my name is Amazon, and if you want to
Mm-hmm.
speak with me, you basically and
Right.
sometimes it's even more than you have this published language in additional, right?
Mm-hmm.
So
Mm-hmm.
usually it's kind of bound. You have open host service using published language. Okay, so it's a
Sure.
well-known API, provided.
Mm-hmm. Right. Right.
And the initial and strongest aspect of this classification is because it's enormously affects the team communication.
Mm-hmm.
Okay,
Yes.
so depending on this, if you go with this design that you say my different bounding contexts are implemented by different teams, project teams,
Right.
then the communication will be affected depending on the relationship between the bounded context, and
Mm-hmm.
this is a part of your domain usually.
Yes.
Okay, this relationship is not something we create in software, but
Mm-hmm.
this relationship is part of your domain modeling. So you
Right.
cannot actually change it.
Yeah.
And but there are also technical reasons to think about this.
Of
So
course.
apart from this team communication and what kind of interface you need and what kind
Mm-hmm.
of project management you need across the teams,
Right. Right.
um, and um, so I think one of the let me give you an example. So
Mm-hmm.
I think you had a podcast. I'm not sure if it was with Steven or with Allard about event sourcing and event streaming.
It was with Stephen. Yeah.
Okay,
Yeah.
okay, that was a Steven. Okay,
Yeah.
so yeah, and of course, if you say how he explained event streaming, right? So we were
Mm-hmm.
speaking about Kafka and all this stuff.
Yes. Yeah.
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 So if your context is just streams events,
Mm-hmm.
okay, so independent how it stores it internally and so on,
Yeah.
and it just doesn't care who is consuming them and whatever, and how components react to them,
Mm-hmm.
um, then it's obviously not partnership relationship between the contexts, because it
Right.
just don't care, right? So it's just
Yep.
yeah, and then it's just communicating facts, and
Mm-hmm.
there are no intentions in this fact. So
Right.
this just happened, right? And there
Exactly.
are scenarios where you want exactly that, right? So if you have
Yeah.
some sensors measuring something and it
Mm-hmm.
transforms this data, and then of course, I mean, this happened, right? There
Right.
is no there is no if you
Ifs or
want to
buts about
accept this.
it. Right.
Yeah, I mean, I would like to not to accept that it's actually raining outside, but it's raining outside, right? So
It is what it is.
yeah, exactly. um and it's slightly different if we speak about driving business process, where we have
Mm-hmm.
we have a different relationship between components.
Right.
So because if the next component can refuse a command, that means that you want to know this feedback, and our business process need to react to this, so you
Right.
cannot just ignore it. Okay.
Of course.
um yeah, so if we yeah so if two contexts are speaking with each other,
Mm-hmm.
then there is a notion of this. So first of all, of this translation, right?
Right.
So for this translation, which is the anti-corruption layer from the
Mm-hmm.
DDD,
Mm-hmm.
it might be a good idea to introduce kind of a middleman, because
Right.
otherwise you have this problem of chicken and an egg, and you say, yeah, who is responsible for translating?
Exactly.
um, and especially in technical systems,
Mm-hmm.
if we speak about Java, or Java-based system, there will be, if you're building a translator, there will be at least as long as you're using Java type system,
Yeah.
you will have a dependency actually, right?
Right.
So
Right.
if you need to translate between A and B, and
Mm-hmm.
A is and this translator is located on the A side, it
Right.
will have a dependency to B because it needs to know the classes of B, right?
Exactly.
Which is kind of strange if you say, okay, I'm building an anti-corruption layer which should decouple my bounded context, and then
Mm-hmm.
I put on my bounded context something that I want to translate to because he's next to in my process, right?
Right. Right.
You can inverse this and say, okay, basically you're building the ESCL on the other side, on the receiver
Mm-hmm.
side,
Mm-hmm.
okay,
Mm-hmm.
which is kind of natural. So if you draw the diagram, the
Right.
ESCL is usually put on the receiver side in the
Mm-hmm.
DDD context maps.
Mm-hmm.
But that means that the receiver must know who is sending commands to him,
Sure.
which is
Yep.
kind of also very strange in terms of,
Right.
yeah, kind of, I mean, I mean, we are speaking about software design, right? So,
Right.
and yeah, to solve this problem, sometimes it's just advisable to say, we have a middleman. So we have
Exactly.
someone who actually is doing this technically. So the
Mm-hmm.
SEL is logically on the receiver side, but
Right.
technically there is a middleman who is responsible for just knowing A and B. A and B
Mm-hmm.
can completely independently develop their context and change
Right.
the APIs.
Yeah.
And then there is a guy in the middle who is saying, okay, I know what fields needs to match. Okay, so
And
I
I think
need,
that's when we also, as you mentioned, it's important to know which system is sort of upstream and which system is downstream. And I think that's important to mention that that's when the design comes in, and that's why we always talk about when we're designing a system. It takes quite a bit of time because you want to be aware of these quote unquote future changes or things that you want to evolve within your application. So I think it's important to uh, note that which system you want it to be the core system and which system you want to be supporting system, and which system can be a completely third party. You can just give it to somebody else, an off the shelf,
yeah.
kind of system that you can use. So it's really an interesting um, conversation, which I will have some at some point in the future to really talk about those business decisions, because we're eventually trying to resolve this domain need that we have, right?
Yeah.
And the domain is the business model that we have, and we have to based on what kind of requirements that we have on this business, then the technical aspects of it sort of trickles down from that. And so yeah, that's a really important thing that you just mentioned. Whereas which one is upstream, which one is downstream, where's this translator in between, where's this middleman has to be in between, so that it doesn't necessarily affect the functionality of either system, and you can just develop your systems and grow them as you wish. And even in the future, you can make one of the systems completely a third party system again. You can just say, oh, this system, I don't want to deal with maintaining it or what have you. There's an off the shelf system that I can use easily, and that way you can just make that a system out of your basic design and systems and so forth. But yeah, please continue. You were you
Yeah,
were
it was.
saying.
I was just wanted to mention it's very interesting. I'm a lot on this business process management,
Mm-hmm.
basically, yeah, kind of domain of applications and so on.
Right.
And Ben Drucker, who's one of the founders of Camunda BPM, so one of
Mm-hmm.
these process engine products.
Yeah.
He's a lot in this DDD and CQRS and this kind of what kind of orchestration patterns, or is it a choreography or orchestration, how does it
Mm-hmm.
work?
Yeah.
And he speaks a lot about this this kind of integration patterns between bounded contexts. So what
Right.
happens, and the interesting part there is that sometimes it's very difficult, as you said, what is the core system, right? So it's
Right.
very
Yeah.
difficult to decide if you have a complete business
Mm-hmm.
line in front of you, which
Right.
includes from order placement to maybe production and shipment. So
Yeah.
what is the core of it? How you decide where it is? And
Exactly.
it's kind of important to understand, and
Mm-hmm.
what business process management people tend to do is to say, the core is the end-to-end process.
Right.
So there is no
Yeah.
core in terms of what business bounded context at the core,
Sure.
but there is a business process which is, which gives us the value from,
Mhm.
so the value chain from the start, from the order placement to the shipment. So this is the
Mhm.
core of our business.
Right.
And then, of course, we need the individual functions, like, we
Of
need the
course.
inventory, and we need the payment
Right.
service, and we need the production.
Mhm.
But
Mhm.
there is no something like, who is core and who is dependent.
I
And
guess it would
this,
come down to like which one is the moneymaker, right?
yeah, but in the end, it's the entire business process.
Of
If you just
course.
produce stuff, but you cannot sell this, you have a
Right.
lot of stuff, but it's not there. The
Yeah.
inventory is full. If
Right.
you if you just sell but you don't produce, so all the parts should fit together, right?
Sure. Yeah, absolutely.
That's why, he denotes, as a pattern of external orchestrator, right? So he says,
Mhm.
like, this in terms of DDD, you will have something like, you have bounded context, and
Right.
they are tied up together to the end-to-end process by this
Right.
external orchestrator. And then
Mhm.
there is, of course, a very interesting discussion if is the external orchestrator actually an own bounded context or not, or is it
Great.
just glue between existing bounded contexts? And this is very, very advanced.
Yeah.
Kind of to sum it up, if you communicate across bounded context, so
Mhm.
you will definitely require event handling component that
Mhm.
is able to send commands, right? So this
Yes.
is, you cannot avoid this.
Yeah.
As soon as it's usually stateful,
Mhm.
right? It should be a Saga in Axon Framework.
Right.
Okay.
Yep. Yep.
Otherwise, you will stick up, with subscribing event handler,
Mhm.
and yeah, but you should be stateful, and you should not actually, from the point of view of coupling or
Yes.
decoupling in this
Decoupling.
case,
Yeah. Mhm.
you don't want to couple two bounded context inside of the same unit for work,
Yeah.
right?
Yeah.
So they
That's a
should be
no-no.
decoupled.
Yeah.
Exactly, they should be decoupled. If they are decoupled, the only notion of, running a common transaction is to
Mhm.
try it. If it doesn't work, compensate it, right? Okay, so
Right.
this is
Right.
a usual way how you act in, uh, you know in a compensation sphere.
Right.
And this is completely okay, and the Saga is the way to go there,
Right.
definitely.
Absolutely.
um but uh, just a spoiler, it won't be easy, right? So because you have, as we speak, I mean, we're speaking a long time for now, but it's, we
We're
it's
just scratching the surface,
yes,
really,
we have
because
to
there's
think
so
about a
much.
lot of stuff here. Yeah.
Yes, of course. And we always recommend, whenever we get questions regarding sagas, can you manage whatever you're trying to manage with an event handler, with a simple event handler? If that's a yes, then don't use the saga. But
Yeah.
if that's a no, and you have to, as you mentioned, it has to be stateful, then you can use saga, but really be aware of how you use it, and also really pay attention to again, we go back to the design of the application and design of your systems to make sure
I
that
had
actually works.
I had a very easy, if you're writing serialization tests for Saga and you
Right.
find out that you don't have anything to store,
Hmm.
probably you don't need a
So
Saga.
use the saga.
It's very
Right.
easy.
Exactly. Exactly. I like that. That's a really good way of looking at it as well. So, Simon, would you like to add anything else that? I mean, there's a lot more to
I mean,
talk about, but we can talk hours and weeks
exactly,
about
exactly.
this.
Yeah.
But you can be sure I will come back and have a lot more questions for you, and we can continue the discussion. But I really appreciate you taking the time today and going to some of these really interesting topics in a little bit more depth with me. I really appreciate it.
Thank you, Sarah. Thank you for having me.
Thank
It
you.
was a joy as usual.
Thank you. It's a
And
pleasure. Pleasure is mine. Thanks so much, and I hope you have a fantastic day.
thank you. Bye bye.
Bye bye. Thank you so much for listening to my talk with Simon. I hope you enjoyed it. Please tune in next time as I discover more about Axon and its ecosystem. Until then, have a great time and happy coding.